This is question 7 on the AP Chapter 9 Review Multiple Choice Questions. For a one-sample test for a population proportion P and sample size n, why is it necessary that n P naught and n times 1 minus P naught are both at least 10? Okay, this is the condition that guarantees that the shape of our model is the sampling distribution for sample proportions is approximately normal. So that is answer C. The sample size must be large enough to support an assumption that the sampling distribution of the sample proportion is approximately normal. So let's talk about why some of the other answers are wrong. Answer A. This is a condition only for the mean. Okay, n greater than 30. And actually, this isn't even anything that would be a condition at all. We can take as large of a sample as we want, but if the distribution of the population isn't normal to start with, a larger sample from that population will not make the distribution of the population be normal. So this is not a thing at all. The sample size must be large enough to support an assumption that the distribution of the sample is approximately normal. If the distribution of the sample is approximately normal, that can be a support for saying for the mean that we think the distribution of the population could be plausibly normal. But once again, it doesn't matter how large the sample is, it would just be the shape that would be concerned in. The sample size must be large enough to support an assumption that the observations are independent. Independence would be coming from a sample being less than 10% of the proportion of the population, not a larger sample. The sample size must be large enough to support an assumption that the sample proportion is an unbiased estimator of the population proportion. Sample size, once again, has nothing to do with that. That assumption is met if we take a random sample. Then that is the condition for the mean being the unbiased the sample proportion being an unbiased estimator of the population proportion. Okay, so let's go to question number 8. In a population of bats living in a certain region, 30% have a wingspan greater than 10 inches. So that's the population proportion P, 30%. In a random sample of 80 bats living outside the region, 20 had a wingspan greater than 10 inches. So that is our sample proportion, 20 out of 80, which would be 1/4 or 0.25. So P hat is 0.25, P is 0.3. Consider a one-sample z-test to investigate whether there's evidence that the proportion of bats with a wingspan greater than 10 inches living outside the region is different from that of the bats living in the region. Which of the following is the correct test statistic? Okay, so we have to do P hat minus P. Okay, so that eliminates 30 minus 0.25. We want the 0.25 first. So we're down to D and E. 0.25 minus 0.30, P hat minus P. Then we have to look and then how do we do the standard deviation? Is the standard deviation of our model for a test based on P hat or based on P? It is based on P naught, the null hypothesis value. So this has to be not 0.25 and 0.75, but 0.30 and 0.70. If we were doing a confidence interval, we would use this standard deviation because we wouldn't know 0.3, we would only know 0.25. We would only know our sample. But here we know the population, hypothesized population value, and that is what we base our model on. Okay, so it is E. This problem has data for swimmers, seeing if they could swim better or faster with their head shaved or without their head shaved. So they take 6 swimmers, they time them without shaving their head, and then they time them after they shave their head. So these are paired data. Okay, each pair of data comes from a single swimmer. So the reason, and they even mention mu d representing the population of the differences. So if this is paired data, we're not going to do a 2-sample t-test. We're going to do a paired t-test, We'll talk more about that, the difference, as we get into chapter 10, because in chapter 10 we will be doing 2-sample t-tests. We'll talk about when do you do the 2-sample versus the paired. But if you notice that the two samples are not independent of each other. In this case, they're definitely not independent. The time before and after shaving for a single swimmer would be very dependent on that swimmer's ability. So we can't think of these as two independent samples. By the way, the previous problem was 14 and this one's 18. And these were problems that were requested by some students in the survey that I had you do, which some of you didn't do. For a certain brand of canned corn, the company claims that the mean weight of the contents of the cans is 15.25 ounces. A random sample of 36 cans were selected. The sample was found to find a mean of 15.8 ounces and a standard deviation of 0.12. A hypothesis test will be conducted, etc. Okay, so how do you do the test statistic for the hypothesis test? It's going to be X bar, sample mean, minus mu, population mean. Okay, so the company's claim would be the population mean, and then they specifically say the sample mean is 15.8. So first of all, we would eliminate any place where the 15.25 is first, because we want sample minus population. So C, D, and E are automatically eliminated. So now let's look at A and B. The standard deviation is the sample standard deviation divided by the square root of the sample size. So this one kind of fooled you because the sample size is 36, but they didn't put a square root sign here. 6 is the square root of 36, so that is the square root of n right here. Okay, the next one we're going to do is number 22, and that's the last one that anybody requested. If you want me to do any more of these, I definitely will. Okay, number 22. A distribution of mass for United States pennies minted since 1982 is approximately normal with mean 2.5 grams. Okay, so if we're doing a mean, it says a random sample of 10 pennies minted since 1982 is selected. The sample had a mean of 2.47 grams and a standard deviation of 0.04 gram. Notice that we have a mean and a standard deviation for our sample, but we only have a mean for the population. We don't know the population standard deviation. Therefore, we cannot use a normal model. We have to use a T model, because a T model is the model that allows for some extra variability when we don't know the mean of the that we don't know the standard deviation of the population. So it's a T distribution. So we're down to 9, or D and E. We can't use a normal distribution. And then the degrees of freedom is 1 less than the sample size, so that's why it has 9 degrees of freedom. Hopefully this was helpful. I'll be glad to explain any more questions that you have concerns about or that you didn't understand.